Okay, welcome to Calculus 2. We are going to be talking about volumes of revolution by using the method of shells. So in this case, determine the volume of the solid of revolution formed by revolving y equals x minus x cubed about the y-axis. We're given that y equals 0, and then that x is constrained between 0 and 1. First thing I'm going to do is I'm going to draw a little picture here. Okay, if I look at this x minus x cubed, okay, we'll go ahead and set this up. So we have x, 1 minus x squared. So we have x is equal to 0, set this equal to 0. 1 minus x squared equals 0. So we have 1 minus x, 1 plus x equals 0, and x equals 0. Fortunately, we are given that x has to go between 0 and 1. So if I'm looking for other things, that it could actually go between -1. But since they told us it has to go between 0 and 1, we're going to be between 0 and here's 1. Okay. Knowing what the y equals negative x cubed looks like, something like this. Okay. But this is going to kind of bounce. It's going to be up like that. Okay. So we can go ahead and do something like this, knowing that this is kind of out of bounds. Okay, but we would have something like this going on here. We want to revolve it around the y-axis. So we're going to be taking this little piece here and dealing with it revolving around the y-axis. In the method of cylinder, in the method of washers like we did last time, we would actually want to get this little bit of a dy here, but then we'd have to figure out, okay, we need this piece minus that piece. And that's going to be kind of tough to deal with. Okay, that's going to be a lot of algebra to do some things that are not so good. Okay, the method of shells, what this allows you to do is we actually take a slice that is parallel to the axis of revolution. And this is going to be my little dx piece here. So what we're going to do is we're going to say the volume is, okay, so our formula is equal to 2 pi integral from a to b, in this case 0 to 1. And then we're going to say it's x times f of x dx, and that's going to be my volume. So we're going out to a certain value, we're multiplying by the height, and we're spinning this piece around as we go, something like this. Okay, we're going to add up all the tiny little pieces, all these little cylinders, all of these little shells until we have this one little piece here. So let me go ahead and put in what we have here. So we have volume is equal to 2 pi. Then we have 0 to 1. We have x times, and my height is going to go back up here, and it's going to be x minus x cubed. Okay, x minus x cubed dx. And then this is what we actually want to go ahead and integrate. Well, okay, I got to go ahead and multiply this out. That's not too bad. So we're going to say 2 pi integral. We have an x squared minus an x to the fourth, all times my dx here. All right. So now it's time to integrate. So integrating this is pretty simple. It's just power rule. So we have 2 pi. We're going to be integrating. So that's going to be adding 1. So that's going to be x cubed over 3 minus, we're going to be adding 1. 4 plus 1 is 5. X to the fifth over 5. And we're going to be evaluating between 0 and 1. And that's what we're going to have here. So we have 2 pi. Here we have 1 over 3 minus 1 over 5, right? Minus, let me go ahead and do it this way, minus, and then if I plug in 0, all of that is going to be 0, all right? And that's going to be kind of nice. So we have to go ahead and get common denominators here. You guys are allowed to use a calculator. That's fine. So we have 5/15 minus 3/15. This is all times 2 pi. So 5/15 minus 3/15. We end up with 2 pi times 5 minus 3 is 2 over 15. So my answer is going to be 2 times 2 is 4 pi over 15. Okay, and that would be my answer for like this weird sort of mound-shaped thing that we've revolved around the y-axis here. Okay, and that's like kind of the first one that we're going to do here. Next one. Let me pause you for a moment here. Okay, so here we are. We are finding the volume of a revolution enclosed by the solid enclosed by y is equal to the square root of x minus 2 from y equals 0 to x equals 4 about the y-axis. Okay, so let's go ahead and draw a picture. Okay, So we're going to be able to say something like this is 1, 2, 3, 4. So when x equals 2, we have y is equal to 0. So that's great. So we're going to look at something like this. All right, and it's just the square root function going for x up to x equals 4. Okay, so let's go ahead and revolve this around the y-axis here. So we're going to be able to do that. So I'm going to be able to say I want to go from, okay, here we're going to go from 0 to 4. We're going to go out here. So we're going to draw a little line here. This is the piece that's going to go. So it's going to be x times, and then my height is going to be the square root of x minus 2 dx, right? Now, I'm looking at this, and we got two functions that are multiplied together, and you don't have a way to do that. Remember, we had two functions multiplied together. When we take derivatives, we had to use the product rule. We're going to have a similar rule in integration, but we're not there yet. So I have to do something else a little bit here. So I'm going to say, you know what? Let's go ahead and say let u equals x minus 2. And what that'll do for me is my du will simply be dx, okay? But what do I do with this x here? And I don't know what to do with that just yet. So what I'm going to do is I'm going to say, well, we cast u in terms of x's. Why don't we cast x's in terms of u's? So we're going to be able to say this is u plus 2 is equal to x, okay? Now, the other thing I'm going to do at this point is I'm going to say when x is equal to, boy, oh boy, oh boy. Nope, we don't get to go from 0 to 2. We have to go from 2 to 4 because y has to be equal to 0. We're not going to be able to do anything before that. So we have to go from 2 to 4. Okay. So when x is equal to 2, then u is going to be equal to 2 minus 2, which is equal to 0. Okay. When x is equal to 4, u will be 4 minus 2, which will be 2. Okay. So we're going to go ahead and have our little piece here. So we're going to say u is going from 0 to 2. And now what is x? X is actually, I can't use x's anymore. I have to use u's. So we have u plus 2. All right. And then what we're going to do here is we're going to say, okay, now we need to have my u is equal to x minus 2. So we still have u raised to the 1/2 power here. And of course, we have a du because dx was du. Okay, that's an integral I can actually go ahead and deal with. Okay, so we can go ahead and integrate this out. We have 0 to 2. And we're just going to multiply this through. So this is really 2 to the 2. So when the bases are the same, we add the exponent. So this is going to be u to the 3/2. I haven't integrated yet. I just multiplied this out. Plus 2u to the 1/2, all times du. Now we're ready to integrate, because now I can integrate this thing. Okay, so we're going to go from 0 to 2. We have u, we're going to add 1. So we have 5 over 2 and divide by 5 over 2, which is the same as multiplying by 2/5, plus 2u. We're going to plus 1 here. Sometimes I like to write like a 2 over 2 here to make it clear that it's going to be 3 over 2 and divide by 3 over 2. So times 2 over 3. Okay. And we've already integrated, so we don't need that anymore. And we're going from 0 to 2. Okay. So let me clean this up a little bit. So we have 2/5 u to the 5/2, right? What are we doing here? Okay. Plus 4/3 2 to the 3/2. Okay, so that's what we have for that. All right. For that, we're going to be able to say we have 2/5. If I plug 2 in here, this is going to be u to the 4/2 times u to the 1/2. Can I do that? That way it makes the algebra a little bit easier for me. So u to the 2/2 is really u squared. 2 squared is 4 times the square root of 2, right? Because 2 to the 1/2 is going to be here. Plus, here we have 4/3. 2 to the 3/2, that's going to be 2 to the 2/2 times 2 to the 1/2. So 2 to the 2/2, that's 2 to the 1. So we're going to have times 2 square root of 2 here. Minus, when I plug 0 in here, both of these terms are going to get to be 0. So that goes away for 0. So don't let me forget the fact that we had, way back when we set this up, we had a 2 pi out here. We had a 2 pi out here. Yep. And we have a 2 pi all the way out in the front here. Okay, so we're going to have a 2 pi all the way out here. So here we have 2 times 4. So we're going to have an 8 square root of 2. Okay, 8 square roots of 2 all over 5 plus, let's say it's 4 times 2. So that's also going to be an 8 square roots of 2 all over 3, all times 2 pi. You guys are allowed to use a calculator for this. That's fine. I'm going to go ahead and say we have 3 over 3. We have 5 over 5. So we have 3 times 8 is going to give us 24 square roots of 2. 5 times 8 is going to be 40 square roots of 2. This is all going to be over 15 times my 2 pi. So let's see here. We are going to end up with 2 and 4 is going to be 64 square roots of 2 all over 15 times 2 pi. And that gives me 128 square roots of 2 pi all over 15. That would be my exact answer for a problem like that. Okay, so that's what you're going to do with this. You're going to learn one thing in calculus 2, especially with definite integrals, is setting up the integral is usually the hard part. The integrations aren't the hard part, but the arithmetic when you're done, that's the hard part. Okay, so that's usually a thing that we can go ahead and deal with. All right, let me go ahead and pause you while we write down the next problem. Okay, so here we go. The next example is find the volume of revolution of the curve y is equal to 2x minus x squared above y equals 0, but about the line x equals 4. So we're not going to be revolving it around the y-axis. We're going to be revolving it around x equals 4. Let's draw a picture. Okay. So things that I have to do here is we have to take a look at y is equal to, this is 2x minus x squared. Okay, and we know that y equals 0 is the boundary on the bottom. So we're going to set this equal to 0 so we can go ahead and figure out what happens here. The first thing I'm going to do is factor out of x. So we have x times 2 minus x, and that'll give me back this whole thing here. It's set equal to 0. So we have x is equal to 0. 2 minus x is equal to 0. So we have x is equal to 0. X is equal to 2. Okay, so we have here's 0, here's 1, here's 2, 3, 4. This is where we are revolving. Okay, so this is what we're going to revolve around. So we have x equals 0 and x equals 2. So we have kind of a parabola that's looking like this. Okay. I know that if you have a parabola, the way you find the vertexes, you can average the intercepts, and I'll give you the vertex. So that vertex is going to be at 1. So 2 minus 1 is going to be 1. So we're up here at 1. And we're taking this whole thing and revolving it around this whole axis over here. Okay. So we're going to take this whole piece and have it revolve around something like that. Right? So to figure out this volume, say V equals 2 pi, 0. And then what are we going to be going ahead and taking this to? Well, the x values, the function goes from 0 to 2. Okay. And now what we have to do is we have to get what is our radius? And our radius is going to be 4 minus x. Okay. So the 4 minus x is going to be the radius part of this thing times my height, which is going to be 2x minus x squared. 2x minus x squared dx. And we'll set up all those little pieces here. So if I draw my little rectangle here, right, we're trying to sum up all of these tiny little shells to go around and get these pieces here. Okay. And this is what I'm going to go ahead and want to integrate now. Now, there's fancier ways to do this, but we're not going to do that. We're going to go ahead and multiply this out. So what we have to do is we have to say, okay, volume equals 2 pi integral. And now I'm going to go ahead and just multiply this thing out. Okay, so it's going to be from 0 to 2. So we're going to have an 8x, right? That's 4 times 2x minus a 4x squared. Okay, that's going to be that piece. And we have a minus here. So we're going to say minus 2x squared, right? That's my minus x times 2x. That's minus 2x squared. And then we're going to have a plus x times x squared, which is going to give me an x cubed, right? So that's what we're going to have there. Let me go ahead and make this a little bit clearer, make this a little bit nicer. So we have volume equals 2 pi integral from 0 to 2. Okay. And now what we have here is we have an 8x, looks like minus a 6x squared plus x cubed. And we have a dx under all of that stuff. Okay. And now it's ready. Now we're ready to go ahead and integrate this thing. So we have volume equals 2 pi. Let's go ahead and integrate. So we have 8x squared over 2 minus 6x cubed over 3 plus x to the fourth over 4. And we're going to be going from 0 to 2. We don't need a plus c because we already have our definite integral here. Okay. So now we have to plug in some pieces and deal with all of this. Okay. So let's go ahead and we can say we have v equals 2 pi. Okay, 4 over 2, we have 4x squared minus 6 over 3, 2x cubed plus 1/4 x to the fourth, going from 0 to 2. Okay, so to go ahead and figure that out. So let's go ahead and piece these parts together. So we have volume equals 2 pi. Okay, 2 squared is going to be 4, so we have 4 times 4 minus 2 times, well, 2 cubed is 8, so 2 times 8 plus 1/4, and we have 2 to the fourth. 2 cubed is 8, so 2 to the fourth must be 16. It's from song. So here we go. We have 2 pi. We have 16 minus 16 plus 4. This piece is going to cancel, so we actually end up with 0 times plus 4. So we have 4 times 2 pi, which gives us an answer of 8 pi. Okay, and that's how you would do a problem with that. Right? So that was a little tricky because it, we don't have the axis at the, we don't have the axis of revolution at the coordinate axis. We have to move over. So in order to do that, we had to go, okay, 4 minus x is where we're going to actually look at for what our radius is. Okay. So sometimes we have to do that. Those are a little bit trickier, but I think you've gone far enough for this one. I got a nice problem for us, but I'll do that in the next video. And I'll say thank you very much for watching. I will see you in the next video. Take care.